year 1800. This major breakthrough occurred when scientists passed sunlight through a variety of coloured filters and noticed its heat output changing. Infrared light sits outside the visible light spectrum for electromagnetic radiation, meaning we can't see it with our regular human eyes. However, that doesn't mean we don't experience infrared every day. In fact, any object with a temperature above absolute zero or minus 273 degrees Celsius emits radiation in the infrared region, whether that's an ice cube or the sun. To actually see any of this radiation, we use a process called thermography, which transforms an infrared image into a radiometric one with an infrared camera. These cameras display temperature measurements across individual pixels. The finer the radiometric resolution of a sensor, the more sensitive it is to detecting small differences in reflected or emitted energy. Resolution is more important in infrared imaging than it is in digital photography, because it directly affects the accuracy of temperature measurement as well as image quality. A larger detector size produces an image twice as wide and twice as high, with 4 times the data for a given field of view. This makes a thermal imaging camera a perfect tool for automotive diagnostic applications. An automotive thermal imager is a specialised device used for non-contact thermal measurements, with the ability to visually reveal heat sources to help identify vehicle faults. But how does this actually work? Infrared energy emitted from an object is focused by optical lenses on infrared sensor elements. The detector elements create a very detailed temperature pattern called a thermogram, which then changes into electrical impulses, sending the information to a signal processing unit for translation to image processing and final display on an LCD screen. Most thermal imaging cameras scan at a rate of 9 times per second and can measure temperatures from minus 25 degrees Celsius to 550 degrees Celsius. They can detect changes as small as 0.2 of a degree Celsius. Most cameras also feature an automatic calibration function to ensure accurate and consistent measurements. Thermal imaging cameras are most commonly used for engine, transmission, final drive, brakes, turbos, HVAC, and even electrical fault diagnostics. So let's look at some common applications for a thermal imaging camera in your workshop. A brake in the rear window defrost heating element can be located using the thermal imaging camera on the rear window. The brake in the element grid can be seen as a cool area in the window. High resistance connections, such as a poor earth or loose and dirty connections, will also show up on a thermal camera, along with any excessive relay current draw. Even parasitic battery drain, when power discharges after the vehicle is switched off, can be detected with a thermal imaging camera. Engine misfires can be time-consuming to detect with conventional tooling and usually requires a minimum of a power balance check or a compression test to diagnose. But now there is an easier way with thermal imaging cameras. A misfiring cylinder does not produce as much heat energy as a good cylinder, so the weak cylinder exhaust won't be as hot on the exhaust runner as from the cylinders that are firing normally. A thermal image can also reveal if a misalignment of pulleys is causing overheating and putting stress on the belt and shows as a hotter section of the belt. Thermal imaging technology is a great tool for in-cabin diagnostics. Simple cabin HVAC leaks can be located by closing all doors and windows, switching the HVAC system to hot and noting any leaking air past the door seals with the hot image. Using the thermal imaging camera for a heated seat issue, by comparing the thermal image from both seats, we can locate a non-functioning heating element which shows up as cold. HVAC issues can be quite tricky to locate, as they are behind the dashboard assembly and access is limited. However, using the thermal imaging technology, restricted vents, stuck blend doors, or motor actuation problems can be easily located. The diagnosis of bearing issues in drivelines is another example of effective infrared-based diagnosis. A failing bearing inside a differential or gearbox can be identified by viewing the component with the thermal imaging camera. A failing bearing produces excessive heat, which is seen as a white and yellow area in the housing. A failing wheel hub assembly can be also quickly identified by the bearing overheating and the excessive friction displayed as a bright white and yellow area on the hub. Finally, common mechanical brake system faults such as seized or sticking brake calipers, hydraulic system issues and brake bias issues can be detected using infrared. Incorrect brake compounds can also be identified by excessive brake temperatures in some instances. As you can see, this latest technology makes it easy to pinpoint abnormal temperatures on a component that is not working efficiently or may be facing imminent failure. They also allow technicians to more easily show customers an image of a vehicle fault, adding more credibility to the repair quote. As thermal imaging tools continue to become more cost-effective for automotive repair shops, it makes effective diagnostics a whole lot simpler. Remember, to keep up with today's technology, continuous training is paramount. Thanks for watching.